Hello there, welcome to Math at Ease, and in this video I am going to take up the topic of rationalization of denominators. So let's quickly move on to the board. So here I am. We are going to rationalize the denominators of fractions where you have irrational numbers as some of the terms. Okay. It's also called as simplification of surds. Now what are surds? Surds are irrational numbers again where the number part is actually a whole number. Like as you can see, root 3 is also called a surd. Okay. And what do we mean by rationalization of denominators? Just like fractions, we always try to express in the simplest or the lowest terms. Irrational numbers, if we have in fraction form, then we always try to put it in a form that the denominator is rational. Okay, the numerator can be irrational, but we try to always convert the denominator to a rational equivalent part. Okay, before we start with the actual method, you have to remember 4 important formulas, I can say, or important identities that you will be using a lot in this particular topic, whether it is rationalization or not, but in the concept of simplification of surds or simplification of irrational numbers. Now what are they? The first one is root a times root a is always a. For example, root 2 times root 2 is 2. Okay. The second one is root a times root b is always equal to root of a times b. Okay. Root a divided by root b is the same as root of a over b. And the most important one is the last one, which you have studied as an algebraic identity in your previous classes. Root of a plus root of b times root of a minus root of b is always equal to a minus b. It's the same as a plus b into a minus b is a square minus b square. Okay. Now how do we use this particular concept? Let us start working with the example that I have taken. I have taken a simpler one to start with, and then I'll move on to complicated ones. So here, as you can see, the denominator is having an irrational part, root 3. And I want to do something by which I can remove the irrational part. Okay. And this is where the last identity comes into effect. Whenever you are having a question like this, what you will do is you will multiply the numerator and denominator with the same term as you have here, but with the opposite sign. So I will multiply this with 2 minus root 3, and since I cannot multiply just the denominator, I do that with the numerator as well. So overall, if I see these two cancel out to 1. Okay. So what happens is, here you will be relating this times this with this particular identity. Now this particular term 2 minus root 3 is called the rationalizing factor, okay, of the term 2 plus root 3. So now let us expand them. Denominator gives me 2 plus root 3 times 2 minus root 3, and numerator you will expand 3 with, multiply that, and then let's move down. I will have to open the bracket on the top. 3 times 2 is 6 minus 3 times root 3 is 3 root 3 over. Now this is where we use the identity. If you see, this is a plus b and a minus b. So it will be a square. So 2 square minus root 3 square, which will give me 6 minus 3 root 3 over 2 square is 4 and root 3 times root 3 as I mentioned on the top is 3. So that gives me 6 minus 3 root 3 is my answer. I can write it as over 1 and I may not write also here. This is the special case where I got my denominator 1. But as you can see, the denominator is rationalized. Okay. So this is actually equivalent to my original number, which was 3 over 2 plus root 3, but with the added thing that the denominator is rationalized. Okay. Let me move on to a second example. Okay, I can have a question like this. If 3 over 2 minus root 2 is equal to a plus b root 2, then find the values of a and b. Okay, so here also the main idea is to make the denominator rational. So we start by taking our original number where the denominator is having an irrational part, and we try to look for the rationalizing factor of the denominator. So as I told you, the numbers will be the same, only the sign will be opposite. So I will have my rationalizing factor as 2 plus root 2, and the same number I multiply on the top. Then I try to expand the numerator and denominator separately. So in the denominator, as you can see, you have the term a minus b and a plus b, which will give me a square minus b square. Okay, and the numerator I will just have to multiply by expanding the terms. I'll get 6 plus 3 root 2 over 4 minus 2, which will give me 6 plus 3 root 2 over 2. Okay, now if you see, if you try to relate this to this, you may not be able to get the answer at the first instance. So what you can do is you can just separate the parts. So 6 over 2 plus 3 root 2 over 2, which will give me 6 over 2 is 3, and this is, I can just leave it as 3 over root 2. I can even write it as 1.5. Now what I do is I try to relate it with my a plus b root 2, which will give me my values as a is equal to 3 and b is equal to 1.5. Okay. So this is another common way of asking the questions, where you use the same concept of rationalizing the denominator. Now let me take a third question, which is little more complicated than this. So this is a question where I am having two different fractions with an addition sign. So we try to rationalize the denominators, or the question can be simplify the expression. Okay, so there are two methods now. So one method is I can try to solve this separately and this separately and then combine both the answers, or the easier method in this case is, if you can see, the denominator here is 4 minus root 5 and here it is 4 plus root 5, and if you can observe, they are both the rationalizing factor of each other. Okay, so what I try to do is either I can combine, or to make it easier for understanding, let me multiply this with the rationalizing factor 4 plus root 5. Okay, then there is this plus sign. For the next one, the rationalizing factor will be 4 minus root 5, if you observe carefully. Okay, then I try to simplify here. I'm using the identity here, so it will be 4 square minus root 5 square. And if you see, the numerator is nothing but 4 plus root 5 times 4 plus root 5. Similarly, here again it's 4 square minus root 5 square. 4 minus root 5 times 4 minus root 5. Okay. Now, those of you who remember the identity a plus b whole square and a minus b whole square can directly write down the answer for the numerator here. But before that, let me simplify my denominator. It will be 16 minus 5. Okay. And here, if you expand these two together, or you can even use the identity, I will get a square plus 2ab will be, my 2 4s are 8, plus 8 16 root 5, no sorry, it's 8 root 5. Okay, we'll get 4 root 5 and 4, and then a 5 which is root 5 square. And similarly here I'll get 16 minus 8 root 5 and again plus 5, because even negative root 5 times negative root 5 will be 5. And denominator again here it is 16 minus 5. Now, what will my numerator here give me? 16 plus 5 is 21 plus 8 root 5 over 9 plus 16 plus 5 again 21 minus 8 root 5 over 9. Okay. Now, if you would have observed one thing, our denominator has already become rational. Now, since it is a common denominator 9, I can take it, and 21 plus 8 root 5 plus 21 minus 8 root 5, which will give me, if I cancel these two, 42 over 9 is my final answer. I can write it in my simplest form or the mixed fraction form. Does it go? Yes, it goes with the 3. It is 20, it's 14 over 3, or 4 wholes 2 over 3 is my answer. Okay, so that's the value of the expression. Hope it's clear to you, and this way you can make use the concept of the identity to rationalize your denominators. The other method that I was mentioning was, instead of taking each of them separately, here you can combine them together and take your LCM, which will be nothing but this times this, so that this gets multiplied with this and this with this, but at the end you end up with the same answer. Okay. If you have liked the video, please like my channel and subscribe my channel. Okay, thank you.